Let's try to solve a classic dynamic programming problem called 0-1 knapsack problem. So the problem says that we have got some items with weight, each of weight wi and a profit of pi. Okay, and there is a thief, and the thief has a bag of capacity c. Okay, so it can carry up to c grams of weight, you can say. Okay. So we have to tell like what is the maximum profit that the thief can obtain by picking one of these items. Okay, we are given the weight and the profit, and we have to kind of come up with the maximum profit that the thief can make given this capacity. Okay, now first thing is like what the first solution that can come to your mind is like the first intuition that you can get is why not pick items of max profit. Okay, why not pick items of maximum profit? So there could be two reasons not to do this. One is like if you pick the items of maximum profit, you might not be able to fill the bag completely. Okay, what I mean is there's capacity C, and let's say the item that you picked is like, or let's take a more concrete example. Let's take the capacity C is 10, and then the maximum profit item that you take had weight of 9. Okay, and let's say it had a profit of whatever 6, anything. Okay, now there is no way, there are no other weights which with value 1, right? Because if you pick this item, you have only weight capacity left as 1. Okay, so that is one way. Another way is you don't know that, let's say this capacity, this profit is 6. What if there are other items like with smaller weights? Okay, let's say that I have got a weight 1 and profit of 3, and weight again 1 and profit of, let's say, 4. I can pick these two, and so with just 2 weight, like 2 units of weight, I am making a profit of 7, right? So if I pick the items based on the maximum profit value, I'm missing these scenarios. So this solution is not correct, right? What could be another solution? Like you can think that why not pick the items with minimum capacity. Okay, pick items with min capacity to optimize, to increase number of items in the bag. Now what could happen is you might have missed one item which was like way heavier. Okay, so let's say there were like 3, let's say there was an item of capacity weight 3 with profit of 5. Okay? Then there was an item of capacity weight 4 with profit of 6. Okay, and let's say there was another item of item with weight 3 and profit of 5. Okay, and let's so you pick these 3, and let's say there was another item, okay, of weight let's say 5 and a profit of 100. Okay, so if you pick these 3, because these 3 are the minimum capacity items, if you pick these 3, then you just able to accumulate the profit of 16, right? So you miss this one. So again, this solution won't work, right? Similar as this solution. So what we can do here, okay? So again, this is a classic dynamic programming problem. So think about it. See if recursion works. So, okay, so the first question you should ask is, will recursion work? Means, can I break this problem P into sub problems P1 and P2, and then make sure by solving P1 and P2 I'm able to find the solution for P. Okay, is it possible? So let's see. So what we have to do at every step, so we are given 2 things, right? We are given a capacity C, okay, and we have to maximize the profit, and we have let's say a list of n items out of which we have to choose. Okay, Now let's say I pick the first item. What are the options that I have? I have two options, right? Either to pick or don't pick. Okay, either to pick that item in my bag or don't pick, right? So these are the two options that I have, right? What happens if I pick the item? So if I pick the item, then what would happen is, out of now I am left with n-1 items, out of which I have to pick, and I picked let's say the first item. Okay, so now let's say it had a weight of w1. Okay, so what happens is my capacity is reduced to w1. Okay, and whatever profit I make with these values, like with this condition, I would add like the weight of the first, we would add this w1, and that would be one of my answers. Okay, so if I pick, I am able to, or rather p1, I'm sorry. So this is the total profit that I can make if I pick the first item. If I don't pick the first item, then what happens? So if I don't pick, my capacity remains as C, and I am left with n-1 items. Okay, so these are the two options that I have. Now if I choose a maximum of these two, right? Let's say this gave me value, this first one gave me value of 6. The first the profit of the first item was, let's say, 5. So I would do an addition. 6 plus 5 is 11 if I pick the first item. If I don't pick, let's say this gave me a value of 16. Okay, so I know that I don't have to pick the first item, right? So we can use this as a function. So let's say this is a function, then I pick, then this is the function call would be on C minus W1 and n-1, and then if I don't pick, then the function call would be on C and n-1. Okay, so you can see that the recursive solution will work, right? And what we are doing is, like, we are not picking based on any condition, but we are seeing like each and every possible condition that can happen, right? So for each item we are taking the decision based on whether we should pick or don't pick, right? So we are exhausting all the options, right? So that's what dynamic programming does. To solve any particular problem, it looks at all of the sub problems, okay, and the solution to all of its sub problems, and then it picks the best one. Okay, so that's the first thing. So we know that recursion will work here, right? So I know that there is a top-down solution exists, right? Now this was our step 1, okay, to find the recursive solution. Now step 2 is adding a memoization. Like, this is called as memoization. You can also call it as like tabulation, or you can name it whatever you want, but the idea is to like store the values, right? Now in the previous problem we just had one parameter to our function, right? But here we have like two parameters, right? So to store the value, we would have to take a two-dimensional array, right? Why? Because at any point of time we have two things, capacity and the number of items that are left. So the function would be called, the recursive function is getting called on two parameters. So the table that I'm going to create should be based on two parameters, okay? So, which is basically, it should have 2 dimensions, so which is basically a two-dimensional array, okay? Now I'll add a memoization to it, and then I can reduce the number of calls, okay? So that is the second thing. Let's try to write a code for this one. Okay, let's try to write pseudocode. Okay, so what we can do is, let's say this is my function of max profit. Okay, and then I have a capacity C, and then I am given n items. Okay, and then like there are 2 more inputs, which is like an array which contains the profit of the ith item, or let me write that. So there's another array which contains the profit, and there is another array which contains the weight. Okay, so this is the function. Now what I would do is I would create a two-dimensional array somewhere. Let's call this data tab. Okay, so if I would say is if tab of C and N not equal to -1. Okay, we'll initialize. So -1 means that this value is not filled in the table. Then, so if it's not equal to -1, we would just return the value from there. Okay, so return tab of C and N. Okay, so now after this condition, now what we have to do, we have to calculate, right? So what we can do is we would say tab of C N equals. So what happens, like this first time, like I'm picking an nth item. So if I'm picking an nth item, what is my profit? P of n. And then the next call that I'm going to make, max profit, would be on with C minus W of n. Why? Because I picked that item, so my capacity is reduced now. Second parameter, and now I am only left to pick n-1 items. Okay, and what happens is next one is P and W, we will just pass as it is. These are not going to change. Okay, so this is when I am picking. When I'm not picking, then what happens? My profit will remain as it is. Okay, but we would call max profit with the capacity C. Okay, and then n-1 items yet. Okay, and then P and W. Okay, so and in the end we have to take a max of these two. Okay, so that's what we have to do. All right, and then I'm just going to return. Okay, now it's a recursive function, right? So recursive function must have base condition. What would be my base condition? If there are no more items left to pick less than equal 0, then simply return 0. Okay, all right, so this is a pseudocode. When you write the program, you can write the program yourself and and check. Okay, but this should work. So the idea is similar to the previous question that we discussed, which was like the Fibonacci sequence. Here also, like here instead of like one parameter, we have two parameters. So we have to create a two-dimensional array. Okay, but the idea is same. We are just storing the values of the function calls. Like so the two parameters are C and N, and whenever we are finding a value with C and N, we are storing it in our function. Okay, so this is again added a memoization. Okay, now what is the next optimization? The next step is to write it into a recursive solution. Okay, so which is also called as bottom up. Okay, what we would do is, again, we would create a table of size, say C plus 1, and if you have n items, then use n plus 1. Okay, and then you have to initialize this properly. So if the capacity is 0, so for C equals 0, it's going to be tab 0 and whatever, all 0 to n index will be 0. Why? Because if the capacity is 0, then there could be no profit, right? Okay, and if I have to pick a profit of 0, okay, so this is my table here. Let's see this. 2 dimensions here. So this is one, this is another. Okay, 0, 1, 2, 3. So this way, like these are my columns, like profit. Okay, so in this dimension I'm capturing profit, in this dimension I'm capturing the weight. So for 0 weight, I cannot get any profit, right? So everything is going to be 0, right? Similarly, if I have like 0 profit, if I have to get like 0 profit with 1 weight, it's not even possible, right? Oh, this, I'm sorry, this is number of items. Okay. So capacity is 0, but number of items are 3. Then this is, if the capacity is 0, no matter like how many items are there, the profit will always be 0. If there are 0 items, no matter how much big capacity bag I have, the profit will always be 0. Okay. And then whenever I am like, now we'll start from here, C11, this is the first value that we have to calculate. And to do that, like again, I'll see we have 2 options. If I pick, then I would pick that much weight. So I have to see like whatever is the weight. So 1 minus whatever is the weight of the first item. So weight of 0. Okay. And then how many number of items are remaining? If I'm picking this one, if I had 1 in the beginning, okay, so I'll be left with 0 items. Okay. And if I don't pick, then what happens? My capacity of 1 remains the same, but again, this one would like number of items would still be 0. Okay. And then I have to pick the max between these two. One thing you have to be careful about, like when you're writing the code, is like this should not be less than 0. Otherwise this would be an array index out of bounds exception. So you have to put a check here. Okay. And yeah. So how I came up with this solution, like how I decided. So whenever you are creating a 2-dimensional array, you have to decide how you're going to iterate. Like, so there are a number of ways to iterate, right? So what I mean is, I can iterate like this. Okay, like this. This is one option. Okay, another option for me would be to iterate like this, right? Like column, going into each column from top to bottom. Okay. Another option for me could be to like iterate like this, right? Means starting from the bottom right and then traveling from right to left. Okay. And then there could be another options, right? Like traveling, going like this, right? So how I decided that I have to traverse like this, okay, like this. Why I did that? Okay, so how you can figure that out is for every C and WN. So for every Ci, let's take Cij, and I represents my this dimension, and j represents this dimension, which is number of items, and this one is the capacity. Okay, so for every Cij, you see like I have to subtract something. Okay, so this would be go. So if suppose now, let's take this table, and suppose I'm here. Okay, this currently I'm calculating the value for this Cij. Okay, so what could happen is I have to subtract something from here, right? So I must know the values of all the rows before this, right? Pardon me. Okay, so if I have to calculate the value of this one, so if I'm picking, I'm going to some row above this one, right? You see, I'm subtracting, right? The logic would be like I minus whatever is the weight of the second item, right? So I'm going somewhere in the row, any of the rows above. Okay, if I'm not picking, I'm staying in the same row, but I'm reducing the number of items to pick, which is, so if right now I am just looking for, I have to calculate for 2 items. So if I'm not picking, I have to calculate for like any number which is less in this row. Okay, so you see, if I am here, I should know the values of all the rows above this cell. Okay, and also all the columns in this row before this column. Okay, so that's why to fulfill this condition, you have to traverse There's only one way to traverse, like this. Okay. So that is the only decision that you have to make. It's how to traverse, how to kind of create an array. Okay. So that would give you the iterative solution. So the only thing to keep notice of, like while converting the recursive solution to the iterative solution, is like what are our states at any particular time in the table. So what I'm storing here. So this first dimension is my capacity, and so what does this represent? If I say tab ij, what does this represent? This says that what is the profit that I can make with capacity I and j items. Okay, so that's what this represents. And to calculate that, what we are doing, again, we are doing the same thing. We have two options. We can pick the jth item, or we don't pick. Okay, don't pick. So if I don't pick, my solution would remain as whatever is the profit with I capacity with j minus 1 items, which I have already calculated, right? And if I pick, then I am adding the profit. Okay, so I would say I'm picking, I'm adding the profit of the jth item, but what is the remaining profit that I can add? So if I'm picking jth item, what am I left with? Profit of j. I added the profit of j, but in the capacity I have to subtract, right? So weight of jth item I have to subtract, and then I can only pick j minus 1 more items. So these are my two values, and whatever will give me the maximum would be the answer for ij, any ij. So I'll just calculate that. I already explained like why I'm traversing from left to right. Okay, I can just calculate ij for every c and n, and then in the end I would just return tab of whatever c and n. So this would be my answer. Okay, so stay tuned for more videos on dynamic programming. I'm going to explain few more classic dynamic programming problems. We are going to code them on LeetCode as well, and I'm going to also come up with like a series of dynamic programming problems. So like there could be a series of problems based on Knapsack, which are like directly like Knapsack or can be converted to a Knapsack problem. So stay tuned for all of those. We are going to cover dynamic programming extensively. So thanks for watching.